according to this expression, we now have eta t times this plus is equal to 0, okay? Or eta t times this is minus omega over c squared times d. So how to solve this equation? Okay, you can try this strategy. I multiply the inverse of eta t. So we have this inverse times d. Okay. So you can find the eigenvalue of eta t inverse, and you take the square root to get the eigen k vector. Okay. So to do this, we can define a new matrix called N. Before we turn on the perturbation part of the epsilon, we originally have this epsilon epsilon 0 times epsilon x epsilon 0 times nx squared, ny squared, nz squared, okay? If there is no perturbation of refracting this, no active optical activity, then we have epsilon inverse being written as epsilon 1 over epsilon 0 times this 1 over nx squared, 1 over ny squared, 1 over nz squared, okay? And the eta 0 without perturbation, eta 0 is just epsilon 0 times this epsilon inverse is this form. Okay, so this tells us that the eigenvalues of the eta matrix is nothing but the inverse refracting indices. Okay. So maybe we can define some index matrix called N. Then we square it. We get index squared. So the index squared to time the eta matrix becomes 1. Okay. Now we want to use the eta t matrix. Eta t matrix. So we define this 课本的4.12之4写成1是错的，因为这边应该是单位组成2乘2的单位组成。The textbook formula is incorrect. The right-hand side of this equality is a matrix 2 by 2 unit matrix, not 1. So we define N as the matrix that is square times eta t equal to unit matrix, which means that N squared is nothing but the inverse of eta t matrix. Okay. If we can find such a matrix N squared, then this means that this equation, when I multiply N squared from left hand side to both from left to the both side of this equation, we get partial zeta squared b is equal to minus omega over c squared times n squared times b. Okay. Wait. So if we allow to define a matrix N, so the matrix N squared is equal to the inverse of eta t, then we get this equation. Now we use a trick similar to what Dirac did in studying the antiparticle problem. We take the square root of the matrix if we write this as we factorize this equation. We can factorize this equation. We factorize this equation as this. So there are two ways to satisfy to obtain the final result. We have two possible ways to get the final result. The first way is the second. Since we have already argued that the M matrix is nothing but the index matrix, okay? So if we get the refracting index, we multiply the refracting index